Alright, in this video we're going to look at working with arithmetic series. So an arithmetic series can be found by adding the terms of an arithmetic sequence, just as any series can be found by adding the terms of its sequence. So without using a calculator, let's see if we can find the sum of the first 100 natural numbers. In other words, 1 plus 2 plus 3 plus 4, all the way up to and including 100. And again, the key is not using a calculator, so we can't just put the rule into our calculator and then have it generate it for us. So let's say the sum, we'll call it S for sum, is whatever it is, 1 plus 2 plus 3 all the way up to 100. And now let's write this sum again, but in reverse order. So here's our sum. Let's write it again in reverse order and add the two sums together. So we have S going from 1 to 100. We also have S going from 100 down to 1. Because remember, it doesn't matter what order we add numbers. So what we notice here is we have 101, 101, 101. We have a bunch of these sums of 101. In fact, we have 100 of these 101 values. So we had S here plus another S here makes 2S. And then over on the right-hand side, we have 101. We have that 100 times. And so if we divide both sides by 2, we get 100 divided by 2 is 50. 50 times 101 is 5,050. So without using a calculator, we're able to actually determine what the sum of this series is from 1 to 100 by some clever manipulation of the values. Now, the reason we have this example here is because it leads into what the formula for the sum of an arithmetic series is. So the method of solving that example suggests that to find the sum of an arithmetic series, we need to take the first and last terms and add them together. So all these 101s we got was the first term of 1 plus the last term of 100. Take all those terms, the first and last term, add them together, and then multiply that by half the number of terms. So when we have the 100 values here from this one, this one, this one, all the way up to this one, there's 100 values there. We divided both sides by 2, so we took half that number of values, and that gave us our result. So the sum of an arithmetic series is half the number of terms times the first term plus the last term. So in the next example, what we're going to do is, because we do encourage the use of technology, I'm going to ask that you find the number of terms n that are being added. So example 4, find the value of n in each that's going to make each of the following true. So in example 4a, we have 5i minus 9, where we're going to start with I equals 1 and go up to and including I equals n. And that result is going to be 1,400. Now, rather than guess and check for values of n, instead, we're going to solve this systematically. So our first term that we get is what when we plug in our lower limit of 1 in for I, and we get 5 times 1 minus 9 is negative 4. So our first term, negative 4. Our last term is what we get when we plug in our upper limit, which in this case is going to be 5 times n minus 9. And then we have the sum is 1,400. It's half the number of terms times our first term, negative 4, plus our last term, 5n minus 9. Simplifying inside the parentheses, we get 5n minus 13. And then distributing the 1/2 n to both terms, we get 2.5 n squared minus 6.5 n, still equal to 1,400. Get it equal to 0, and we'll have 2.5 n squared minus 6.5 n minus 1,400. This is factorable. They have to be factorable. However, I would encourage you to maybe check where this graph on the right hits the x-axis. You'll see it hits it at negative 22.4 and positive 25. Now, because n does represent an upper limit of summation, number one, we can ignore any values of n that are negative, and also ignore any values of n that are decimals. So our only legitimate value for n in this problem is n equals 25. And the nice thing is we can then plug it into the calculator from 1 to 25 of 5i minus n, or 5i minus 9 rather, and it should come out to equal 1,400. All right, part B, same type of problem, our first term, we're going to plug a 1 in for our lower limit in. We get 6 times 1 minus 11 is negative 5. Our last term is 6 times n minus 11. And we're going to have 2,460 as our sum. So 2,460 equals n over 2 times our first term is negative 5 and plus our last term is 6n minus 11. So simplifying inside parentheses, we have 6n minus 16. Distribute 1/2 n to each of those terms. We get 3n squared and minus 8n. Get this equal to 0 by subtracting the sum from both sides. And now we'll get n is negative 27.3 repeating, and then 30, which the only valid answer here is 30. By the way, you'll never have two valid answers for n. So one of them's you're going to have to disregard. The other one, the positive integer value of n, is the one you want as your answer. All right, part C. Here we have for 1 minus 2i for our rule, but this time we're going to start with I equals 0 and not I equals 1. And I have a note here to be careful with this one, simply because we're no longer starting with 1 as our lower limit. We're starting with 0. So our first term is what we get when we plug in a 0 for I. So 1 minus 2 times 0 is 1. Our last term is when we plug an n in for I, so we get 1 minus 2n. However, normally from 1 to n, there are n terms. Like from 1 to 100, there's 100 numbers. But if we start at 0, we add that 0 term in. So it's no longer going to be n terms. By adding in the 0, we actually have n plus 1 terms. So for instance, from 1 to 100, if we start with 1 and go to 100, there's 100 numbers. But from 0 to 100, there's 101 numbers. So we've got to count that 0 as an additional value, which means that additional value goes in this numerator. So that's why I said be careful with this one. Simplify inside parentheses, you get 2 minus 2n. Here I just took half for each to get rid of the fraction. So half of 2 is 1. Half of negative 2n is negative n, and we still have the n plus 1 in the numerator. Multiply this out, we get negative n squared plus 1, which is really nice because we can subtract 1 from both sides. We get negative 400 equals negative n squared. Divide both sides by negative 1, and then take the square root of both sides. We get plus or minus 20, which, again, we can't have a negative value for n. So n equals 20 is our final answer. All right, so a lot going on in this video, but that about does it for this one. Thanks for watching, and I'll see you next time.